Well, welcome everybody, and thank you for attending our presentation. We'll be talking about personalized visualizations to promote young learners' self-regulated learning, and we developed a learning path app for that, which we'll be explaining in this presentation. But first, let me introduce myself. My name is Inge Molenaar. I'm an assistant professor at the Radboud University in Nijmegen. And I'm running the Adaptive Learning Lab over there. My co-authors are Anne Hovers, who's been developing and designing the Learning Path app, Rick Dijkstra, who's been developing the app, and we've been fortunate to work with Ryan Baker in this particular development, and he has been helping us on implementing the moment-by-moment learning curve algorithm within the app. But first, before I start talking a little bit more about the app, let me explain the context in which we are working. We're working in primary schools in the Netherlands, and children are ranging age 6 to 12. And within these schools, typically students work with adaptive learning technologies on a daily basis. And that means that for their math and spelling and grammar exercises, they'll be working on the tablet technologies, and at the same time these technologies centralize the role of the teacher, and they're implemented in what we call blended classrooms. So both the technology and the teachers play an important role. Teachers still continue to provide the instruction and provide elaborate feedback to students, whereas students practice on the technology. And if we zoom into that a little bit more, we see that students receive direct feedback from the technology, and the technology adjusts the difficulty of the exercises to the needs of the students. And at the same time, teachers receive dashboards that provide information about what students, how students are performing in the classroom, and also provide additional information about individual development of students. And we've been publishing on how teachers use these dashboards in these contexts extensively in other publications. For today, I'd like to zoom in further on what the role of the student is in these adaptive learning technologies. And there have been some concerns with respect to the fact that the technology takes over quite a bit of the control from the students, and it takes away some of the agency and autonomy that students have over their own learning process. And in doing that, it may prevent students to build important self-regulated learning skills. And these skills are important not only to improve current learning, but also for future learning, so that students are able to monitor and control their future learning activities. Now, of course, within these adaptive learning technologies, lots of data are being recorded that can help learners not only indicate what they have learned, but also how they have learned. And that's exactly where we'd like to develop learner-facing dashboards that help learners see how they learning processes evolved over time, and when they were executing enough control and accuracy, and when they could have increased their regulation activities. So in order to do that, we've been developing the Learning Path app to help students see how their learning evolves over time, and so that they can build on these regulation skills. And in doing so, we've been working in the COPES model of self-regulated learning that has been developed by Phil Winnie and Alison Hatwith. And let me run you briefly through this model. In the first phase, this model is talking about the internal regulation of students. And in the first phase, it is talking about task definitions. So students need to get a good overview of how they are performing a task. The second phase is about planning and goal setting. And it's important that students get a good idea of what their learning goals are, and also that they create standards to which they can uphold their own learning goals. Next, the third phase is the actual learning phase, in which the different strategies have to be executed. And it's important that students engage in monitoring to see if they are actually reaching their learning goals. And in order to monitor, they create a vision or assess how well their products are evolving, and they, in cognitive evaluations, see if these products are reaching their standards. In case that works out fine, nothing needs to be done. In case that is problematic, students should elicit control exercise activities and actually engage in these control activities. These are also called small-scale adaptations, and they occur during this execution phase 3. And then, of course, there's also the reflection phase in which further adaptations can be made at large-scale adaptation, which is after the actual learning phase has been taking place. Now, in working with adaptive learning technologies, it's important to note that there's also external evaluations that sort of complement to what students do in their internal evaluations. And the actual direct feedback that I was talking about earlier, as well as the adjustment of the difficulty level of the exercises, are both indications where the adaptive learning technology takes over part of the regulation from the students. Here it provides additional information about how students are performing, and here it provides adjustments to the control activity, so it takes over some of that control. And what we're trying to do with the Learning Path app is actually build a layer in between the internal and the external regulation of the students in order to help them with the data that we collect in the system to understand their own regulation processes better. In the first task, and I will zoom into these screens in a second, in the first phase that engages an overview, and the second phase it engages a screen where they can engage in goal setting. Then the overview screen evolves over time, as does the goal setting screen. And then importantly, in the last phase, we provide them with what we call learning pathways that show them how they have performed and how they have learned during this particular session. Now let me zoom into these different screens for a moment. In the task definition phase, students see the overview screen and they can get a better understanding of the different tasks that they'll be asked to do during particular lessons. Then they'll be asked to set their goals in the goal setting phase, and we ask them to set their ultimate goal, so how well do I want to master this particular skill at the end of the term, but also their in-between goals. Specifically, how far do I think I will be mastering this particular skill after one lesson, and then later on, how much do I want to improve during the repetition lesson. And in doing this, we use the feed up, feedback, feed forward framework that is taken from the feedback literature in order to help students develop these perceptions. Then in the enactment phase, the overview screen evolves and students can see what they have learned based on the precision of the dolphins, how many different exercises they use to do this, as visualized by the size, and different attributes indicate whether or not they reach their own and their overall goals. And then the final phase, the most important phase for the Learning Path app, is when we are showing them how they actually reach these goals. And so they'll be able to see one of these 5 screens depending on the learning path that they followed. And these are translations from the moment-by-moment learning curve into 5 standard representations so that students can easily identify to which learning path they followed. The first one is the high swimmer, and those students actually were already able to, they actually already knew the skill to a large extent before starting to learn. We have the quick riser, which is comparable to the immediate peak. And what we see here is that students learned very early on in the activity. Then we have a riser in 2 stages, and this resembles the double peak that we found in previous work. And that indicates learners that learn early on, as well as learners that learn during practice. And there are 2 distinguishable moments when they actually engage in these activities and learning. Then there's the slow riser. These are students that learn a little bit slower with more iterations, but still learn early on during the lesson. And we have the riser and descender, and those are students that continue to learn throughout this the lesson, but also seem to have problems in regulating their behavior. And earlier in this paper that we presented at LAC last year, based on these moment-by-moment learning curves, we indicated that there were 4 different groups of students that needed different support for SRL. Also, additionally, because there's a lot of information in the app, in the classroom when we're running this experiment, there are additional posters, and sorry that this one is in Dutch. This is the poster with all the information on the logic of the screens. This poster is more important. This is the poster where students can see which learning curve they are following, what it means, and what their resolving actions could be. So let's turn to the research that we engaged in. The research questions we're addressing in this first experimental study is what is the effect of these personalized visualizations in the Learning Path app on students' regulation of practice behavior. And specifically, we're looking at how well they uphold accuracy, how well they regulate their effort, and whether or not there is an effect on the actual learning path that they are following. And then we also look at the effects on learning outcomes, where we look at skills. There are 3 skills that are taught within this experimental study. And we look at transfer. And finally, we look at monitoring accuracy, because we expect that the increased regulation of practice behavior and the practice with goal setting may help students to improve their ability to monitor their own learning behavior. We do this in a quasi-experimental design. 92 students participated. They were all in grade 5. The average age was around 10. And this is the design of our study. Important to note that the Learning Path app was used every single time at the beginning of a lesson. So students in the visualized personalization condition were able to set their goals in the first lesson and view the overview screen. And then from the second lesson onwards, they were also able to see the learning path they followed the last lesson, as well as their overview screen as a result of that last lesson. This continued for a lesson around subscale 1, subscale 2, subscale 3, and finally there was a repetition lesson in which students could continue to work on those skills they thought they still needed practice in. There was a pre-test, a post-test with the transfer test, and every single lesson used the same logic. There was instruction from the teacher, guided practice together with the class, individual practice, which was the same for all students, and then adaptive practice, which was adjusted to the needs of the individual students. The skills that were learned in this particular experiment were to calculate the capacity of an object, to translate the capacity into different capacity units, to revert capacity from one unit to another, and the transfer skill sort of encapsulated all these different skills together. Measures we took were the prior knowledge, 8 items per subskill, the post knowledge, 8 items per subskill as well. Gain could be deducted based on that, and transfer test was 15 items. Then for effort, we calculated the number of unique problems that a student completed, and for accuracy, we looked at the correct numbers that were correct problems that were completed. We calculated, we visualized the moment-by-moment learning curves, and these were automatically detected following the rules that are described here. And then they were transformed into the 5 different screens that I explained earlier. If we look at the effects on regulation of practice behavior, we see that there is no significant effect of effort. Students in both conditions made around the same amount of problems for the different subskills. We do see an effect on accuracy. We see that students in the personalized visualization condition show higher accuracy than students in the control condition. And additionally, we see an improved practice behavior for skill 2 and 3 if we look at the actual moment-by-moment learning curves. And let me run you through this particular picture. For subskill 1, we don't see a difference, so we see similar learning curves, and this is the easier subskill that students worked on. Then for subskill 2, that is moderate difficulty, we see that students in a personalized visualization condition show more simple curves compared to more complex curves in the control condition, and this indicates that there may indeed have been an effect of showing the curves to the students in the way they've regulated their practice behavior. And we see a similar transition in for subscale 3, where again there are more simple curves for the personalized visualization condition and more complex curves for the control condition. Then if we look at learning outcomes, we see that there is a significant effect on transfer. So students in a personalized visualization condition perform better on transfer compared to control condition. For the knowledge gains on the subskills, it's less evident. As you can see, the personalized visualization condition performs slightly better already on pre-test, and for skill 2, this is actually a significant difference at pre-test. And we see at post-test that they're doing better compared to the control condition, but we don't really see a large difference in the gain over these different lessons. The only marginal significant difference is here for subskill 3, where we see that students learn slightly faster compared to the other ones. Then finally, we move to the effects on monitoring accuracy. And what we see here is that there is an effect on monitoring accuracy with regard to how often students overestimate themselves. First of all, we nicely see that easier skills, students tend to underestimate themselves, and more complex skills, they tend to overestimate themselves. But at the same time, we also see a distinction between the control condition and the personalized visualization condition, in which the personalized visualization condition tends to underestimate themselves more than the control condition. And this is remarkable because students this age tend to overestimate themselves extensively. So it's quite interesting to see that in interaction with this intervention, they tend to overestimate themselves less. So conclusions, results from this first quasi-experimental study showed an improved regulation of practice behavior, improved transfer of learning, and a reduction of overconfidence, but an increase of underconfidence. It's hard to say exactly if students learned more through this intervention because of the differences at pre-test. And I'd like to take 1 or 2 minutes to talk a little bit more about future studies that we're currently executing. What is interesting in this study is that we only showed them the dashboards at the beginning of every lesson. And future studies, of course, also would like to show the dashboard concurrently during learning. And another thing that we'd like to work on is to make the adjustments in the Learning Path app in such a way that they're personalized and support the needs of the individual students. Let me give you some examples of that. This is a picture of a study that we recently ran where we actually have the dashboards during learning. Here you see the Learning Path app, and here you see this, the adaptive learning technology. There's an API between the two, so there is a concurrent interaction between the two systems, and therefore students can view how and what they've learned on the dashboard while they are learning in their adaptive learning technology, and this makes it quite different from the study that I've just explained. And another thing that we're really interested in exploring further is looking at increasing learners' control and also allowing learners to determine whether or not they would like their exercises to become more or less difficult, and that's also one of the things that we've been working on recently. And finally, we'd like to develop further towards this personalization of regulation, and in that we really like to work on these different layers of the Learning Path app This is the layer here that I've been talking about now, and this particular study was about. And in this layer that we have developed above this, we see that we can give students a little bit more autonomy, a little bit more control over their own learning, and hence they will be able to work on those self-regulated learning skills in more depth. That's it for this particular presentation. Allow me to cue you on a poster of a project that we're engaged in that's also about measuring self-regulation with multiple data streams, and that will be presented tomorrow, or actually today, in a poster session. And that leaves me with thanking you for your attention and thanking my co-authors and Ryan Baker specifically for their collaboration, as well as the Dutch Science Foundation for their funding.